Hey y'all, welcome to this video. What we're going to be doing is solving rational exponent equations. So let's hop into the dang thing. Let's do it. Before we solve rational exponent equations, it's important that we know how to evaluate rational expressions. This is 16 to the 3/4, 64 to the 2/3, 81 to the 3/2. Currently, just looking at that, I have no idea what that's equal to. So whenever we see the word evaluate, we're really just trying to determine what is the value of that expression. What is the value of that expression equal to? So right now, 16 to the 3/4, I have no idea what that value is, but I can rewrite it in radical form and find out. 16 to the 3/4 is going to have the denominator become the index, the base become the radicand, and the numerator become the power, the exponent. So I can rewrite 16 to the 3/4 as 4th root of 16 to the 3rd. And we know that we can break down what the 4th root of 16 is. 16 is 4 times 4. And since it's a 4th root, I need groups of 2. So I'm going to keep breaking down. And what do you know? 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is actually equal to 2. But I don't just have the 4th root of 16. I have the 4th root of 16 raised to the 3rd power. So the value of 16 to the 3/4 is the same as the value of 2 to the 3rd. And 2 times 2 times 2 is equal to 8. So the value of 16 to the 3/4 is 8. Let's practice and repeat the process for the next two problems. 64 to the 2/3. Again, right now, not a clue what the value of that is, so let's convert it to radical form. This will become the cube root of 64 squared. And let's break down the cube root of 64. 64 is the same thing as 16 times 4, and since it's a cube root, we need, groups of 3 to break free. 16 is 4 times 4 times 4. Well, looky there, there's a group of 3. So the cube root of 64 is 4, but I don't just have the cube root of 64, I have the cube root of 64 squared. So 4 squared, 4 times 4, is the value, or 16 is the value of this expression. I want you to try 81 to the 3/2. Let's see if you get the correct result. Did you get 729? Let's see. 81 to the 3/2 is going to convert to the square root of 81 raised to the 3rd power. And 81, that's 9 times 9. So we're going to have 9 to the 3rd power. 9 times 9 times 9 is 729. Now that we have this skill, we're ready to talk about one more thing before we get into solving. The thing we need to talk about here is reciprocals. What is a reciprocal and what does it do? A reciprocal is essentially the flip-flop or the opposite of like a fraction or of a numerical value. So for example, I have 3/4, 1/2, and 18/7. If I asked you to find the reciprocal of 3/4, you would tell me that the reciprocal of 3/4 is 4/3, right? It's just flip-flop. What was on the denominator becomes the numerator. What was on the numerator becomes the denominator. What's the reciprocal of 1/2? Well, we're going to flip it, 2/1. What's the reciprocal of 18/7? That's 7/18. I mean, I could just make up a problem. What's the reciprocal of the number 3? The reciprocal, because this is really 3/1, is 1/3. What we're really interested in is what do reciprocals do when we multiply them together? So let's see. 3/4 times its reciprocal, 4/3. Well, when you have fractions that are being multiplied, you multiply the numerators together and the denominators. So 3 times 4 becomes 12 on the top, and 4 times 3 becomes 12 on the bottom, and 12 divided by 12 simplifies to 1. So when we multiply reciprocals together, they simplify, or this one simplified to 1. Let's see what happens with the next one. 1 times 2 is 2. 2 times 1 is 2. Again, it simplifies to 1. I could do the same thing for the last example, but oftentimes when we multiply by reciprocals, we know this is going to happen. So oftentimes you'll see people just cross-canceling the 18s and cross-canceling the 17s, and it's equal to 1. Same thing with this one. It just simplifies to 1. Now, why might this be important to us? Well, if you think about it, our last slide had exponents that were fractions. So if I'm trying to get rid of exponents that are fractions, I can use reciprocals to reduce them to the power of 1. So let's use this and a few other steps to actually solve rational exponent equations. So the steps to solving are as follows. 1, isolate the rational exponent expression, meaning get the base and the exponent alone on one side. Step 2, raise each side to the reciprocal power. What this is going to do is result in a power of 1 on the more complex side, which is precisely what we want to do. Then step 3 is going to be to simplify and solve for the variable. Sometimes this is just taking a number to a power. Sometimes we have to evaluate that rational expression, and you'll see the varying levels of difficulty. So let's put it to work with our first set of problems. Solve the following equations. 9 is equal to m to the 1/2, and n to the 1/3 is equal to 3. These are the most basic, where there's nothing really going on here, but I'm going to walk you through the steps so that you can see what is needed to be done for each problem. So step 1, isolate the rational exponent expression. So I like to find your exponent and the base immediately below it and put a box. If the box is alone on one side of the equation, then it is isolated. Then step 2 says raise each side to the reciprocal power. So that expression you boxed, look at the exponent. Raise both sides to the reciprocal power. So I'm raising m to the 1/2 to the 2/1 power. And whatever I do to one side, I have to do to the other. Now we know that when we have these exponents, the reciprocals, they cancel out. What's left behind on the right is just the letter m, or whatever the base was. On the left, though, is 9 squared, or 9 to the 2/1. And of course, 9 times 9, that's just 81. So for this problem, it was pretty straightforward. We got 81 is equal to m. You go ahead and try problem number 2. Did you get n is equal to 27? If so, you did it correctly. Let's walk through the steps. The first step is to isolate the rational exponent expression. So if we're going to isolate the rational exponent expression, remember, we're going to need to get that guy all alone. It is alone on one side, so we're golden. The next step is we needed to raise each side to the reciprocal power. Since I had 1/3 as the power, we're going to need to multiply by 3/1. Whatever I do to one side, have to do to the other. Then it's time to simplify. The rational exponents go away on the left, and you're left with just the base of n, and the exponents on the right become 3 to the 3rd. And 3 times 3 times 3 gives us our result of n is equal to 27. Not that bad, right? Let's up the ante a bit. Let's try a slightly more challenging set of problems. Here we have 3,115 is equal to -10 plus n to the 5/3. And problem number 4 is 243 is equal to b plus 7 to the 5/4. Again, we're going to follow the same set of steps to solve for this, and you'll see that it works every time. So step number 1 says isolate the rational exponent expression. So look at problem number 3. Find our exponent and the base immediately below it and put a box. If it is not alone, if that's not the only thing on the one side of the equal sign, we need to algebraically move the other stuff. So how do I get rid of -10? Let's do the opposite. Let's add 10 to both sides. You end up with 3,125 on the left and n to the 5/3 on the right. Our rational exponent expression is isolated. Step 2 is to raise each side to the reciprocal power. So instead of 5/3, we're going to raise each side to the 3/5. Boom. We know the right-hand side is going to simplify to just 1. So the right-hand side is just n. But the left is just like evaluating 3,125 to the 3/5. I need to figure out the value of that. So let's convert that to radical. The 5th root of 3,125 to the 3rd. Now we got to break down 3,125. And if you're not sure how that breaks down, I'll just do that off to the side here. 3,125. That can be broken down to like 25 times 125. And of course, 25 is 5 times 5. 125 is 25 times 5. So again, we can break this down and we have a group of 5. So the 5th root of 3,125 is actually equal to 5. But it's raised to the 3rd power and equal to n. So 5 times 5 times 5 is equal to 125. And that is our solution for n. Now let's move on to problem number 4. Step number 1 says to isolate the rational exponent expression. So find your exponent. See right here. Find your exponent and the base immediately below it. This base has parentheses, so we need to include that. If that is the only thing on the right-hand side or the left-hand side of your equal sign, it's isolated. Then we need to raise each side to the reciprocal power. So the reciprocal of 5/4 is 4/5. Whatever I do to one side, we must do to the other. This is going to become b plus 7 on the right. And on the left, we need to convert this to a radical form. The 5th root of 243 raised to the 4th power. Again, now we're going to have to figure out what the heck is 243 equal to. 243, you can think of this as 9 times 27. And 27 is 9 times 3. And of course, these 9s can be broken down to 3s. So 3 times 3 times 3 times 3 times 3. Oh, the 5th root of 243 is 3. So we have 3 raised to the 4th power is equal to b plus 7. 3 to the 4th is equal to 81. So I have 81 is equal to b plus 7, and we need to get b totally alone. Subtract b from both sides, and you end up getting b is equal to 74 as our final answer. A little bit different than problem number 3, but we can still rely on all of our problem-solving strategies that we've worked up through this entire year and previously to help us solve. Let's do the hardest type of problems. I'll do number 5 and you'll do number 6. This one has more stuff going on, but we again still have just these 3 simple steps to solve. Step number 1 says to isolate the rational exponent expression. So find your rational exponent. Well, find your rational exponent right here. Put a box around it and make sure that's the only thing on either side, on one side of the equal sign. This leaves us with 3,125 on the left if we add 3 to both sides. To isolate is equal to 125x to the 5/3. Boom, done. Step 2 says to raise each side to the reciprocal power. So we're going to raise each side to the 3/5. Boom, done. We know that the right-hand side is going to simplify to 125x. The left-hand side, though, we're going to need to evaluate and simplify. So this is going to become the 5th root of 3,125. And then we're going to raise that to the third power. We just did that in that previous example. So the fifth root of 3,125 ended up being 5. So now I have 5 to the third is equal to 125x. And 5 times 5 times 5 is 125. I'm almost done getting x 100% alone. This is 125 times x. So to undo multiplication, we have to use the inverse operation of division. Ultimately, we end up getting x is equal to 1. Now it's your turn to solve problem number 6. Did you get p is equal to 77? Well, let me walk you through how we did it. So first, isolate your rational exponent expression. We needed to add 4 to both sides. We ended up with p minus 13 to the 1/6 is equal to 2. Then we needed to raise each side to the reciprocal power. Raise both sides to the 6 over 1, or raise both sides to the 6. You end up with p minus 13 on the left and 2 to the 6 on the right. P minus 13 is equal to 64 if I take 2 times 2 times 2 times 2 times 2 times 2. And then add 13 to both sides, and I get p is equal to 77. Awesome. That is how we solve rational exponent expressions or rational exponent equations. Follow these 3 simple steps, no matter how complex it is, and you will be able to solve every time. Take care. Have a good one. Bye.